In this video, we will identify whether a relation is discrete or continuous and its independent and dependent variables. So here we're given either a situation, what our variables represent, or a sketch of the graph. And we're going to fill in our missing pieces and determine whether it's a discrete situation or continuous situation. In this one, we're given the situation, which is student council earns a profit of $5 for each homecoming shirt sold. So we have to figure out our missing information. First, let's identify our variables. Looking at this situation, we need to ask ourselves the question, what thing depends on another thing? So here we're really talking about profit and number of shirts. So we have to ask ourselves, do the shirts depend on the profit, or does the amount of profit depend on the number of shirts? So here, the profit is going to depend on the number of shirts that the homecoming student council sells. So our independent variable is the number of shirts, because the number of shirts is going to determine how much profit we have. The profit depends on the number of shirts. Remember, our independent variable is always our x, so our x-axis here is going to be labeled the number of shirts. Our y-axis is going to be our profit. Then we have to think about what a sketch of this graph would look like. Well, we could sell 0 shirts, and then we would have a point here at 0, and that would be 0 profit. Or we could have 1 shirt, 2 shirts, but I want you to think about, can we sell half a shirt? And the answer to that is no. So our graph is going to look like individual data points, where we sell 0 shirts, 1 shirt, 2 shirts, 3 shirts, and so on and so forth. So is this considered discrete or continuous? Remember, discrete means disconnected, continuous means connected. So here, because our points are disconnected, this relationship is discrete. Next, notice we're given our variables. Our dependent variable is the price of a hotel stay. The independent variable is the number of nights. Let's first start with the graph. For the graph, we know our independent variable is going to be the number of nights. Our dependent variable goes on the y-axis, and it's the price of the hotel stay in dollars. So the sketch of the graph, I want you to think about it as, can you stay half a night? Or would these points be connected or disconnected? So we could stay 0 nights and have a total price of $0. We could stay 1 night and have some cost for that 1 night, and 2 nights, so on and so forth. But there is no way to have 1.5 nights. So these points are going to be disconnected. So once again, this is a discrete situation. Now we need to think about writing our situation statement here. We're trying to describe in words what's going on. So what we have here is the price of a hotel stay depends on the number of nights spent at the hotel. Notice how the description really lays out what the dependent and independent variables are. The price depends on the number of nights. Next, notice we're not given the situation or the variables, but we are given a sketch of the graph. From that, we can identify what our independent and dependent variables are, because our independent variable should always be the x-axis. That's going to be the number of pounds of bananas. And then we have our total price, which should be the dependent variable. Notice how this is continuous. We can buy half a pound of bananas or 0.64 pounds of bananas, depending on how much each banana weighs. So if we buy pounds of bananas and we have a total price, this is actually continuous. To write the situation, we could put some context around what's happening. A store sells bananas by the pound. In this situation, we're given Bob empties his swimming pool at a rate of 10 gallons per minute. So let's talk about the two things that are going on here. We're talking about the amount that's in the swimming pool and a rate at which it's being emptied over an amount of time. So this gallons per minute actually tells us that what our independent and dependent variables are. Our independent is the amount of time. If you ever have time in a situation, time is always going to be your independent variable. And what is depending on the amount of time is the amount of water that's left in the pool. So if we label our x and y axes here, so we have our amount of time, which is our x-axis, and the water remaining in gallons on our y-axis. Now the sketch of this graph, the water remaining in the pool at time equals 0. How much water is remaining? Well, we're emptying the pool. So at the start of the time, we're going to have a full pool. So as time goes on, the amount of water remaining in the pool is actually decreasing. And so this is the sketch of what that graph should look like. Well, there's not going to be an amount of time at which we stop. It's a continuous rate of 10 gallons per minute, which means that this is a continuous situation and not discrete. Our next example, we're given the variables of a height of a tree and the age of a tree. We can label our graph with the age and height. As a tree gets older, the height of the tree is going to increase until a certain amount of time where it starts to kind of level off. So at a certain point, the tree is not going to grow as quickly as it did when it was a younger tree. So writing a situation here, as a tree gets older, the tree grows taller. Is this a discrete or continuous situation? Because all of our points are connected, it's continuous.